Alright, so time for the next question, that is TP based 2D question. And the question is Leetcode 114. What this is this longest common subsequence. So we are given two strings. Let's say example we are given as A, B, C, D, E, and A, C, E. So out of this, what is the biggest or the most longest subsequence that we can build? It's A, C, and E. Length equals to 3. That's literally it. Very straightforward and easy to understand. Literally nothing. So for the brute for purpose, brute is really very simple. So what you do, let's say like there might be a condition where we are given like R, A, B, C, D, E, and here we are given R, A, C, E. So we can just sort it up. So sort this thing, sort string 1, sort string 2, and take a count. So 2 for loop, and count plus plus if we find equal. Then that's literally what of n square actually looks like. Of n square plus n log n, because we use sort. So this is where the time complexity will go, which is not something your professor or your interviewer will be intrigued to see what you have. Now, so we can build this with recursion. This is basically a recursion based question, and let's see how we build it. So we are given two strings. There's nothing much of to worry about. And now we have to look at this is literally similar to how we did this code. Sorry, the Leetcode number 62, that is unique path number 2. That is literally how you will be solving this question. So what we do here is we build a recursion space of 2D. That is, let's say we have A, B, C, D, E. So A, B, C, D, and this is A, C. Let's say this is the thing. Now we know that A is 1, this is 0, 0, B, this is 0, 0, 0, we have nothing to do with here, 0, 1, 0, and D, that is 0, 0, 0. So that comes down to 2. So this is how the recursion should be working. So again, this is very simple. If, so like from the previous code, if this is similar, we just add to the count. That's literally what we're doing, but with recursion. So how that works, function call, so we have text1, text2, and sizes. Let's say we have size, this is size for text, this is the size, and this is the size, let's say. Now what we have to take care of, if so that we don't go out of the bound, we'll start again from here, that is D and E, and build our back down here. That's literally the way we're going to do it, and it's literally simple to build logic diagram, especially how we did in unique path 1 and unique path 2. For that you have to go and look at my video number 2 and 3, so it will be easier for you. So this, and if let's say if n is out of the bounds, if either of them are out of the bounds, then we return 0. Okay, and now if text n is equal to text m, then we say count is equal to 1 plus function. Now this both are similar, so what we do, we say n minus 1, m minus 1. This is what the literally what we're doing here. Else, what we do is count. We take maximum of function n minus 1, m minus, sorry, m, or function of n comma m minus 1. What does this actually mean is, we have this logic, so we have a count. So we have a count for this one, a count for this one as well. So somehow, at some point, we will be getting one for this as well. Let's say if this is 0, we don't get anything common out of it. This will be 0, but this will be 1. So we get count plus 1. Do you get that logic? That's what we're doing here. Now, recursion, we have to solve this over and over again, and somehow you will always run into a TLE, that is time limit exceeded. So we have to come back to TP. What we do here, this is similar to what we did in the previous question. We'll be making a 2D vector, literally similar to what we did here, the unique part. This is the vector that we have to create, the matrix that we need to solve the question. So what do we make? Here we have 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, A, B, C, A, B, C. So how that works? Let me teach you how to make a vector. So matrix for our TP. This is our TP, and let's say this is the size for this part. This is n, and this is m. So this vector, this is m, minus 1. So this is what our TP will put. Now we have to put this whole thing in here, same as that. This is text 1, text 2, then our n, m, and dp. Let's take care of something that memory is storing it, and so that we don't have to worry about the same thing over and over again. Now, what we do, the same thing. If n, we don't go out of the bounds, so it comes here, that's same, nothing different there. As well as 0, 0 and 0. Same. If text n equals to text m, so instead of count, we are using dp. So dp n m becomes 1 plus function call, that is n minus 1, m minus 1. This is the thing that we have to do. Instead of count, we are doing this, so we don't have to evaluate over and over again. The base, you know how to work it out. If dp is not, so we return dp. Simple as that. You know, this is what we have been learning and teaching each other for a while. Else, we say, instead of count here, we say dp of n equals to max of this thing, function m minus 1, or m, or let's say function of n or m minus 1. This is what we do here. And now, in the end, we return dp. And m. That's how you literally solve this question. This is very much similar to unique path question, and go through the Leetcode number 6263 before coming to Leetcode number 1143 for the maximum understanding. The code will be displayed here so that you guys get a proper and better understanding of how the code works. So that's here. Thank you guys so much.